So today, or
You should do question number 2.
what one are we on today?
Today
No, I know. Yesterday was 10:5. Yes. So here we go. Now, again, I kind of like the word problems here, so let's just kind of see if we can make some sense out of it. All right, I thought they were kind of interesting. I thought yesterday's lesson, dealing with tangents, hopefully you agree, wasn't that difficult. But let's take a look. Was there any one in particular that you would like to look at? Which one?
Can you look at number 2?
All right, so it says, Taylor packs a sphere inside a cubic box. He had painted the sides of the box black before putting the sphere inside. When the sphere was later removed, he discovered that the black paint had not completely dried, and there were black marks on the sides of the sphere at the points of tangency with the sides of the box. If the black marks are used as the vertices of the polygon, what kind of polygon results?
Is it like a pyramid on top of another pyramid?
Yeah, I thought it would be like
a
1, 2, 3, 4, and 5.
diamond?
The black paint had not completely dried, and there were black marks on the sides of the sphere of the point of tangency. So how many points of tangency would there have been?
6. Did they close the box?
Wouldn't there be 6, correct?
Yeah.
So let's see. And it's looking at if the black marks are used as the vertices of a polygon. So if I'm not mistaken now, you're looking at a sphere, correct? And if you put it in the box, all right, how many, and if it's securely in the box, then it's going to touch at what?
6 points.
Right, so wouldn't it be at the top, right, if you were putting a point of tangency? Well, let me yeah, so there would be a top, there would be a bottom, and then one here and one in the back. Do you agree with that?
And if it was just a circle, it would be a diamond. And so since you have 2 points that like have a line going through it, would that be like a three-dimensional diamond?
Yeah, so I think. Yeah, to be honest, I'm not real sure why they're.
But then I thought you could make it like a little D of dice because it has like that.
Or just be a cube.
No, it's like that's too long.
It'd be like that.
Yeah, it is. It's like on the point, so it looks like a rhombus.
But it has sides that are triangles, doesn't it?
You don't know that, right?
No, they're not.
Yeah.
Yeah, I think the point they're trying to make here is that it would probably does everybody see now how it's like a pyramid on top of a pyramid, right? Everybody see that? So again, I don't know. I think we're going to be discussing this next chapter. I'm not sure why they are asking you about this. All right, polyhedron. All right. Yeah. So again, I wish they wouldn't have asked that question. I should have just crossed that one out. But again, the visualization is not bad.
Can I
Right.
ask a question on what is
Yes, but let's do that after we get done with this.
Okay.
All right. So question number 2. That's wasn't a big deal. All right. So let's take a look now at question number 5. All right, Amanda wants to make the design of the circles inside. Well, she asked me about 5. We'll do 4 if you need it. Wants to make the design of the circles inside an equilateral triangle. What is the radius of the large circle to the nearest hundredth of an inch? Trying to see if that helps. And this is a equilateral triangle. So I think I try to do that. Right, that should help ring a bell. Anybody have any thoughts yet? Now, do you agree that's an equilateral triangle, right? So then we could say that this is 5 right here, correct? And this is 5. And then this distance from here to here, does somebody want to tell me what this distance is? Come on, guys. 30, 60, 90 triangle.
5 radical 3.
Yes, that's 5 radical 3. All right. So this distance from here to here is 5 radical 3. Now, does anybody remember how that was cut because of what it is? Remember, that's the centroid. So what happens? What does it do?
Can't you just do 5 radical 3 minus?
What this point right here does something special. There's a relationship between that.
Oh, it's 2/3 to 1/3.
Yes.
Can't you just do 5 radical 3 minus 5 radical 3? Even though you use the diameter.
Well, that's also true too, because I think I understand what you're saying. This creates a 30, 60, 90 triangle down here. Is that what you're saying?
I'm just saying that if the whole side's tangent is equilateral, then that the top part would be 5. Whatever.
Well, anyway, if you didn't remember that, you could have seen this right here as a 30-degree angle down here. And that's a 30, and this is 90, so that creates, again, a 30, 60, 90 triangle. Right? So, because it's an equilateral triangle, so all the angles are 60, and if I draw the altitude, it bisects. Right? So, now this, you would say right here, is 5 divided by radical 3, which is 5 radical 3 over 3, right? If you rationalize. So that is 5 radical 3 over 3, which we already knew because this length was 5 radical 3. And if you remember, it's in a 2-to-1 ratio, right? You just divide that by 3, and that gives you that length. And so then this would be double that. Well, that answers that question then, that the radius of the large circle is 5 radical 3 over 3. All right? The large circle is 5 radical 3 over 3. Now, this length right here is also 5 radical 3 over 3. And then this length from here to here would also be what? That's correct, 5 radical 3 over 3. All right, no, I don't think so. Well, I'm saying the radius of the small circle, is that the next question?
Yeah.
All right. Yes, bless you. Yes. What are the radii of the smaller circles? All right. Now.
You have to figure out what that like top.
Yeah.
Are there smaller circles than anywhere proportional to the bigger? We could set up like a ratio or something.
So, yeah, that's a good. So if we found the center, I'm trying to, and I drew from the point of tangency. You see that? That's what I'm thinking of. So that still creates a what? It still creates a 30, 60, 90 triangle. Hmm. Okay, so I can find this distance, where we know that distance is still 5. I'm not sure how I can find the radius. Now let's just see something. Oh, stop. Wow, what does that look like?
It looks like radius.
Yeah, it looks like the radius. I'm not sure how. So, to me, the radius would be 1/3 of 5 radical 3 over 3. So if I had to guess now, I would say it is 5 radical 3 over 9. So everybody see what I did?
Yeah.
All right, let's look just to be careful.
That's probably.
I'm not saying, obviously, that's not a scientific way of doing that, right? But I'm just looking at it, and it seems to be drawn accurately. Do you agree?
Yeah.
So if I was guessing, does everybody see what I did? I just moved that over a little bit. Right, you can see that's pretty good. That's pretty good. So to me, it's 1/3, but I'm not sure technically. Okay, so let's do that as extra credit. If somebody can figure that out, I'll give you some extra credit.
Figure out.
We know it's 5 radical 3 over 9. All right, but I just can't see why. I don't see how to break it down.
Why is
So
it
you
5?
4.
Yeah, we'll do 4.
Why is it 5 radical 3 over 9? Oh,
Well-
it's an equilateral triangle.
Well, what I did was I just kind of measured it, and I know that from here, I know what that distance is. Do you agree?
Yeah.
And it looked like it was 1/3. So I just used my ability to try to measure it. And it looked pretty accurate. Right. So I don't know how. I don't know why it's 1/3. But there must be some explanation of why that has to be 1/3. All right, and it might have to do with similar triangles there. But that's kind of a hint, but I'm not exactly sure. All right, I'm not exactly sure. All right. So somebody asked me, let's take a look at number 4. All right. So it says, a wheel is rolling down an incline. 12 evenly spaced diameters form spokes of the wheel. When spoke 2 is vertical, which spoke will be perpendicular to the incline? All right. Anybody have any thoughts about that?
I just did, so right now 7 is
Exactly.
vertical, and 3 is perpendicular to the incline.
Hold on a second. So again, I just think that was something you could draw out, right? Because that's the point of tangency. Do you agree?
Mm-hmm.
Right. Does everybody see that? Right? And so now we want 2 to be vertical, right?
Yeah.
So isn't that vertical?
Yeah.
Right? So instead of 7, I want that to be a what?
2.
Does everybody agree with that?
Yeah.
So I need to move it,
So whatever's gonna be in that 3 spot.
right? We're moving it how many spaces though? We're trying to get 2 to be vertical, right?
5.
So we're moving it 5 marks, correct? What?
Wouldn't that be moving the roof backwards?
It can be.
Well, I'm meaning vertical, meaning I'm going. Here's how I think I'm moving it this direction.
Yeah.
What doesn't matter which way you move it because the wheels
Really
in the
Yeah.
same place
It's
as the
really
way
good.
Yeah.
options on top.
You can roll it up and it's still the same.
Um,
Just because it says it's rolling
hold
up.
on, let me read that. A wheel is rolling. No, you're right.
Yeah.
You're right.
No,
I was
it
wrong.
doesn't.
You have to go the other direction. I'm not saying it might be the same answer.
Because it's rolling down. So
Right.
It's not rolling up.
Yes, you're right.
I think yeah.
Perfect. So I have to roll it the other direction. Thank you. So it has to be the other direction, right? So if I want it the other direction, and wow, so if 2 is vertical, when spoke 2 is vertical. Now I wonder if they mean 2. Could it be?
You get the same answer. Whether
Yeah.
it rolls down or whether it rolls up.
Yeah, I was just thinking that.
Up's easier.
You with me, guys? Does everybody see that? If you want it to become vertical, that means you want it to become straight up. Do you agree? Is everybody good on that? So if I rotate it this direction, right, I was thinking here it could be vertical, that'd be going down. Right, so we just continue the other direction until it's up, right? Or we can just rotate it what? Backwards. Everybody see that? That's a good visual,
Yeah.
right?
It's
So
10. Yeah.
So let's go back now. So we know we're going to move 2 to this position where 7 is. Do you agree?
Yeah.
So if 2 is where 7 is, that means
It's
you're going to
6.
move it 1, 2, 3, 4, 5 spots, right?
Mhm. So everything's
So everything is going to be rotated 5 spots. So if I start here, 1, 2, 3, 4, 5. Everybody agree with that?
You start what?
10. Right? Because I'm rotating it.
Oh, okay.
Right. Again, guys, those are just good visuals. Tricky and challenging. All right. That was nice. All right. Let's go ahead and get started with today's assignment because, again, I don't think it's too bad. All right. So let's pull up. Which one are we doing? What?
6.
I still have one question.
Oh, yeah. I'm sorry. Let's go back. To which one?
Can you do 5 on page 31? Oh, did I just have to bring it in?
Yeah. 8, 15, 17 is the triple.
I thought.
That's all right. That's no problem. All right. Let's go find. What are we doing today?
10, 6.
10, 6. So pull that up. All right. So today, remember we talked about tangents, and now we're kind of introducing secants. All right, and I try to explain to you that secants intersect the circle at 2 points, whereas tangents intersect the circle at what? 1 point. That's all. All right.
Does it go through the circle or just like?
Well, it doesn't really matter. It's just that you're only going to include the endpoints.
So secant is a chord.
Secant can be a chord or a line. So look right here. Here's what I'm trying to say. Like, if I say that is a secant line, You hear me?
Yeah.
But RS is that chord that's on the circle, formed from the secant.
So it could be a line segment as long as the endpoints are outside the
Yes.
circle.
No, well, the endpoints,
So could RS be a chord and a secant? Or
yes, very true. All right, exactly. All right. Now, believe it or not, there is now just relationships between tangent and a secant, between two secants. All right, and it's very, very easy. All right, so look right here. All right, so these two chords, right, have two angles that were created. All right, now those two angles right there are congruent. All right, do you agree there? It's not; those aren't central angles. Do you agree?
Yeah.
They're not central angles. So they realized that, and it's not hard to prove based off of just triangles that are proportional. All right, but the angle X is the average of the intercepted arcs. So you're just going to say X is 30 plus 55 divided by 2. That's all it is. All right? Yes. All right? So, again, your chords that intersect, there's a relationship between the intercepted arcs and the angle that it creates. All right? Now, here, this is a tangent. Now, is that a 90-degree angle? No, because it's not a radius. It's not a radius. All right? But do you recall if I extended this out, or if I drew it something like this? If I said this was 75, or well, let's make it easy. Let's just say this was 80, then what would this angle be right there? 40. All right. So believe it or not, that formula still applies to the tangent and the arc as well. So look, y, this angle is 84. It's half of the arc. All right, it is half of the arc. All right, does anybody have any questions with that? Now, let's see if that makes sense based off of yesterday. When we drew a tangent line, I'll try to draw a tangent line, and we draw the radius, why is that 90 now? Because?
Because you're using the radius and the diameter.
Yeah, you could just extend that. So I see that now? And so this is a semicircle, which is 180 degrees. Is that good?
Yeah.
So half of 180 is still what? It's still 90. Is everybody okay with that now? All right.
I thought you said the above one was the one above.
Can you scroll up to the one
It is
above it?
not.
Oh, because it is a good thing.
Exactly. All right, exactly. So those are kind of the two little rules that we have for today. All right, or in this particular section. All right, so let's look at angle 1 would be,
I mean, not 15.
46.
who said 46?
Melissa.
She said 44. She didn't say 46. 46 is correct. How do I know it's 46? You add them and divide by 2. That's it. That's how simple. All right. So let's take a look at question number 2. All right. Now, to me here, the sum of the angles has to be what?
70.
No. Some of the angles have to be what? Very good. 90. Right? Does everybody agree with me? Right. So then this has to be, GH would have to be,
I don't understand why it's
45 is equal to.
Oh, yeah.
Oh, so
Right.
45.
So again, look, we would say this. Arc GH plus arc FE divided by 2 is equal to the angle. Do you agree? Now, to me, it's always easier just to say that the arcs add up to twice the angle. Right? All I'm doing is I'm multiplying both sides by 2. You hear me now? So if this angle is 45, right? That means both of these angles have to add up to 90.
Oh, yeah. Okay.
Oh,
Right? If you don't like that, that's perfectly fine. You can just say 28 plus GH divided by 2 is equal to 45. Let me see the logic now.
Also, you could do like you went up 17 to get to 45.
100% correct. Just like the midpoint. You went from 28 to 45. 45 is the average. So you go up 17, go up another 17. All right, so angle 3 would be how many?
110.
110 degrees. Everybody okay with that? 110 degrees? 4. RT would be what?
147, 149.
148 degrees. Very good?
So you do.
60, 70,
Which one?
angle plus.
Well, let's do this. What's this angle here?
1.
60.
How are we getting 60? I could be wrong.
90
Is what?
65.
It's 65.
200 and what?
210.
90 plus 130 is how much, guys?
220.
220 divided by 2. So this guy right here is 110,
What?
which means this over here has to be what?
Because it's going to go too shabby.
70 degrees. Is that what you said?
Yeah.
All right. Now, the other way to look at it is this. Some people look at it this way. Pay attention. 90 plus 130 is what? So the other two arcs have to add up to 140. Half of 140.
Oh.
70. Everybody hear me on that? Does that make sense? All right. These two arcs add up to 220, so these two arcs have to add up to 140. But it doesn't matter how you do it. All right. Yes. Any questions? Go.
But if those two arcs that you have red lines over have to add 440, you can't have them but
Well, remember, it's the average.
okay.
Right? So it's the sum divided by 2. All right. So let's see if there's anything harder here. All right. Tell me.
You did the line is 180.
Good. All right. What about question 6? What's the answer? 100. Right? Because this arc over here has to be 200 degrees.
Oh,
Right? So then angle 6 would have to be 100 degrees. Everybody good with that? All right, again, just more rules. All right? Okay, so now here is where we now have, listen, if the angle's in the interior, it is the average of the arcs. If the angle's on the exterior, all right, formed by two secant lines. Here is the rule. Please watch. It's very, very simple. But again, there are a lot of formulas or a lot of rules that are on your test. All right? So in this case, if the angle's on the outside, instead of adding them, you have to do what? Subtract them. All right? So angle 1 is simply 80 minus 40 divided by 2. So angle 1 is 20 degrees. All right, make sure you heard what I said. If the angle's on the inside, it is the average of the intercepted arcs. If the angle is on the outside, then it's the difference of the arcs divided by 2. All right, any questions?
No.
All right, let's take a look at question number 2. So angle 2 would obviously be what, guys? Right, let's get this done. Angle 2 would be 40 degrees. Now, here we have an issue. What is the other arc?
One time.
I think it's 140, right? 140. So if I go from A to D is 220, then from A to D in the other direction would have to be 140. So it's on the angle is on the outside, so subtract, please, and divide by 2. So angle 3 would be what?
40.
40 degrees. It's very simple. Very, very, very simple. All right. Let's try number 4. So now they're giving you the angle. So what should I do to that angle? Multiply by 2. So then we have 70 minus what is equal to 40?
30.
So that's why this arc
Is 30.
is 30 degrees. Everybody good? All right, let's check out 5. So what is LN?
It's from the last.
Okay.
Like it's supposed to be that you wait. But then when you add 70 and 30 together, you get
Yeah, you
100
get
divided by 2. That's 50. Which doesn't equal 20.
30 minus 7 minus 30 is 40. Divided by 2 is 40.
You don't add.
Oh, minus. Oh, yeah.
Ah.
It's Monday. No,
I
it's
know.
Tuesday.
Wow. All right, here we go.
It's
Wow,
Tuesday.
you have
So help me out with LN. What is LN? Shh.
Would you, so you multiply 50 times 2.
The difference is
100. So it would be
Hold on.
X minus 360.
I want to know what the answer is.
LN and which way?
Yeah.
Okay, let me set it up. Just chill, just chill. X minus 300.
Which LN?
Yeah,
Yeah.
which short? Yeah.
The arc.
Arc.
Which are
Oh,
There's 2 arcs.
Is it 130?
The long one or the short one?
This is a minor arc. We should know that.
Yeah,
Is it
but what
130?
Okay, yes, but how do we know it's not a major?
What?
130.
How did you know it's 130? Shh, listen.
Because there's only 2.
I'm hearing it.
I
Or-
swear to you guys.
Or did you
It's,
overlook her and watch her doing her math?
360 minus 100.
it's 260 divided by 2.
How did you get 260?
Because 360 minus 100.
How did you get?
What?
Oh, is that right? It's 130, right?
You said it was right, so I'm gonna go 130.
It is 130.
Yeah,
How?
it's 130.
Yeah.
I don't care about saying
50 times 2
130.
is 100.
I'm not
360.
explaining it right. Yeah, that's what
160
I
minus
said.
130.
That's what I said.
But how do you know it's 130?
Wait, I got you. This is your trash.
Oh, here we go. Listen to Joe.
The difference between them is 100 because it's a 50.
Yeah, that's
the
what I
difference
said.
between the 2 is 100. And then you do 160 and then add 50 to one side and subtract 50 to the other side.
That made no sense.
No, it's because you have to
Because
count like
Because then you do 180
2.
plus.
Wait. I got
One
something even dumber to say.
So it's 180 plus 180 plus 50 is 200.
That's what
and-
Joe's trying to say.
That's exactly what I said.
Oh, you are.
And then
Joe,
you
you
want-
want-
wait,
it's
can you do the
230.
math for me? It's how it works.
It's
You have to do
it's
it.
120.
Wait, I have the equation, but you
It's
need-
120.
Oh no, he's gonna. No, it's not. It's
No,
130.
it's
It's
Cool.
130.
It's
Hey.
half.
I know, I added wrong. I know, I added wrong. Chill. I did 16
Uh,
cents.
Waited.
So 360
I
minus
was right.
130.
It's half of
I was
260
right.
minus 100.
It is 130.
How was I right?
I have no idea. That's why I asked.
She looked on my iPad.
Oh, I did it. You didn't have the
She
answer.
cheated.
Hey, Again, look up real quick.
I thought 130.
Now, I do like what someone said, and I hate when I have to admit what She said, all right. But here, look, if you forgot that, here's what you're supposed to do. If you forgot that, you can record this as an unknown, which is x.
Yes.
So this over here would be 360 minus x.
Ow.
So then it would be 360 minus x over 2 is equal to 50.
What?
So 360 minus 2x is equal to 100.
With the
260 equals 2x. So x is 130.
I got it right.
I'm smart.
Did I do it the right way?
No, you
Why
didn't.
I did it the right way.
I have no idea what you were talking
Why did you
about.
write that
Did I
None.
got the right answer?
Yeah.
That doesn't
Why
matter.
did you
No,
say
I got the
that?
right answer.
Um,
I got the right
okay, so again, this is kind of nice. So just watch real quick. All right. From L to N and from N to L has to equal 360. Do you agree? So, hey, if one arc is x, the other arc is going to be 360 minus x. Do you agree with that?
Yeah.
Then what you say is that the difference between the arcs divided by 2 has to equal 50. So 30 minus x minus
Okay,
x.
Where do you get 30
That's
from?
what I did in my head.
That's what was.
What do you mean
I
where
said
do I
it.
get 30
You
from?
just said 30 minus
360 minus x. Thank you. What?
like what Joe and I were saying. You
Yeah, whatever. Don't take credit for
Wait,
listening to
here.
Joe
Don't
and then
take credit
repeating
for
what
me.
Joe
I
said.
didn't know that he said that.
Yeah.
Wait, Mr. Stroud.
Mhm. I don't believe anybody believes that.
I've been ignored.
He just did it.
All right.
Oh my god, I'm proud of you. Mr. Stroud, I just did that in my head. Are you proud of me? I wouldn't mind an email.
Shh. Okay, so somebody tell me angle V quickly. Chancellor, we're waiting on you. Say something smart today.
Oh, lol.
Measure B.
As
15.
usual. What?
35.
15.
35.
I doubt it's 15.
I bet you $10.
And 115. It's definitely
You don't have $10.
It's
I
definitely.
do.
It's 15.
35.
Yeah, 35. That's what I said.
I
How do
bet
we
you
get
one
that?
quarter.
Okay, well, you add one time of 80 is 190 plus
Hey,
100
are
is
you sure you're gonna risk
290.
all that money?
260 minus 290 would be
Which would be
35, I bet.
70.
70.
Divided by 2 is
No,
35.
70.
Whoa.
No,
What is the answer
It's
again?
15.
What did you
It's
say?
35.
Good.
That's what I said.
Okay.
I said
So now the
10.
correct answer is
I said
15.
15.
Wait.
Somebody was
Hey,
saying
up!
35.
You said it was 35. I just said, what is the answer? You said 35. I said, are you sure that's the answer? You
No.
said yes, 35.
I
I believe
No,
I get
want
my
my
10 bucks.
I want my
No,
10 bucks.
I asked you what the answer is twice, and you said you
But I said
confirmed.
15. I
Shut
said,
Big-
up.
big way
I
to
said,
take
I bet you $10.
No.
Shut up. And
You're
you said,
wrong.
How
And
it wasn't
this
this
one was
one.
not-
Replay the tape, Mr. Stroud.
Wait,
Replay the video.
Oh, that's a good idea.
It's at
Correct
38.
answer.
Explain that. Is it just are you
Mr. Stroud, write down 38.
Now, hey, listen.
We have like 2
Yeah, it is simply 100 minus 70 divided by 2. All right, so your job is finish up. No. Listen, I'll give you a break. We'll do the ERBs tomorrow in class. All right, 10-6. So go ahead and do those 2 worksheets. Again, primarily you're doing the worksheets to remember the formulas, guys. I keep trying to tell you, don't forget there are a tremendous amount of just formulas on the test. Plugging numbers in.
I forgot to show you my homework right here, in case you needed it.
I'm so
Going dash 4.3 divided by
Do you figure them out?
Okay.